So today we're going to talk about limits, how we figure out a limit by looking at graphs. So we're looking at the graphical approach to limits. So let me grab the page, the same page that you guys have there. I'm just going to put it up here. And we're going to go through this first part here. Let me grab this. All right, so limits. The idea of a limit, what we're talking about with a limit, is what we're interested in is what happens to a function as we get close to something. So we're talking about a particular x value. We're saying what does a function do as we get close to the value. We're not necessarily concerned about what happens at that value of x. What happens when we get close? So the idea of a limit has to do with getting close to something. So on your first page of your packet it says, so we want to graph this rational function. F of x equals x cubed minus 8 over x minus 2. And we can't let x equal 2 because if we put in 2 into the denominator, we get a 0 in the denominator. So we can't have x equals 2 in this rational function. But we want to figure out what happens to our function as x gets close to 2. Now if we look at the numerator and denominator, we can see that 2 is a factor of the numerator and the denominator. So if we plug in 2 for x, the numerator and denominator is 0. Both are 0 at the same time. When we talked about rational functions, what that meant was we had a hole in the graph. So we know we have a hole in the graph here at x equals 2. But we want to figure out what happens as x gets close to 2. So this chart says set your calculator for decimal accuracy, and we want to complete the chart. We're not going to go through all the calculations, but if we were to plug in x equals 1.75 into this function, our function value would come out to be about 10.563. So at 1.75, we're at about 10.5 units. At x equals 1.9, so we're almost at 2. If I plug 1.9 into this function and I calculate, I get about 11.41. So we're pretty close to 2. We're at about 11.41. If I plug in x equals 1.99, just a little bit closer to 2, I get that x equals 11.94 out here. I'm going to go a little bit closer to 2. X equals 1.999. If I plug that into my function and calculate, I would get x equals 11.994. We're getting closer and closer to 12. At x equals 2, we have a 0 in the denominator, so our function is undefined. And that's why we have a hole in the graph there. Well, now we're going to go on the other side of 2, x equals 2. If I plug x equals 2.001, I get 12.006 for my function. 2.01, I would get 12.060. Going a little further away from 2, 2.1, 12.61. A little further away, 13.563. So the limit, the idea of the limit here, we're talking about the limit as x gets close to 2. What does the function do as x gets close to 2? Well, as we get close to 2 from the left-hand side, we get closer and closer and closer to 12. As x gets close to 2 from the right-hand side, I get closer and closer and closer to 12. The function value gets closer and closer to 12. So the next line says it should be obvious as x gets closer to 2, the value of f of x becomes closer and closer to 12. And what we say is that the limit of our function as x approaches 2 is 12. And this is the notation we use to write that. The limit as x approaches 2 of f of x equals 12, or you can just write out the function. As x gets closer and closer to 2, my function value, my y value, gets closer and closer to 12. So that's our idea of a limit. Now, in order for a limit to exist, sometimes limits don't exist. In order for a limit to exist, we have to have, our function has to have the same value as we approach from the left and from the right. So as we go closer and closer to x equals 2 from the left and from the right, we get the same number. So that's how we decide if a function exists, or if a limit exists. If our limit is the same coming from both directions. Our notation for approaching from the left is right there. And this says the limit as x approaches c from the negative. So we're not saying negative c, we're saying from the negative side. We're going from the left. So this is from the left. Coming from the negative side. And then from the positive side, that's this notation. The limit as x approaches some number c from the positive, that means from the right. So this first set of numbers, we're coming from the left, and if we're coming from the right, we would go this way closer and closer to 2. So this is from the left, from the right. If we're looking at our graph, we're coming from the left, we're going this way, left to right. Coming from the right, we're going right to left, closer to our limit. So again, in order for our limit to exist, the limit from the left and the limit from the right have to be the same. And then we say that the limit is whatever that number, whatever our function value is. So what we're going to do today is look at some graphs and decide what the limit is from the left, what the limit is from the right, and does the limit exist. So that's really the point of the entire lesson today, is deciding if these limits exist by looking at these graphs. So let me grab the next portion of your packet and we'll go through that. So we'll look at these first two examples and then we'll look at a few more. So those are the first examples on your page there. So the first column, the first problem here says the limit as x approaches 1 from the negative side or from the left. So I'm tracing along my graph, and we're interested in the function value. We're interested in the y value. What is the y value? So as we're getting closer and closer to x equals 1 from the left-hand side, what is my y value getting close to? 1. So we're looking at the y value here. As I'm going along here, my function value is getting close to 1. So the limit as x approaches 1 from the negative is 1. The limit as x approaches 1 from the positive or from the right. So now I'm over here. I'm coming from the right. What is the function value? What is y close to as I'm coming in from the right? 2. If I'm going here, my function value is 2. So this says, what is the limit as x approaches 1? Are they the same from the left and the right? No. So we say the limit does not exist. It's not the same from the left and right. What's the function value at 1? What does the graph tell us the function value is at 1? Where's our closed dot? 2. Our closed dot here is at 2. So the function value when x equals 1 is 2. That's where our closed dot is. So a couple of things from this first example. The limit and the function value don't have to be the same. The limit is asking us what happens when we get close to this thing. It doesn't have to be the same as the function value. Here our limit doesn't exist, but the function tells us the value is 2. If you go further in math, in calculus, especially calculus 1, the idea of a limit is, it's the key idea of calculus. This is something that is behind everything you do in calculus. So this is an extremely important idea, and extremely important to be able to have an idea of what we're talking about when we're talking about limits. All right, let's look at the next example. So we're finding the limit as x approaches 1 from the left. So we're tracing along the graph. What is my function getting close to as I come in from the left? -1. I'm coming down here, my y value is getting close to -1. What's my function value as I'm coming towards 1 from the positive side? I'm here, my y value is +1. What does the graph tell us the function equals at 1? Where's our closed dot? Y equals 0. Oops, that's not our limit, that's our function value. So what's our limit? Guys, what's our limit as x approaches 1? Does not exist. The limit doesn't exist because it's not the same from left and the right. Our limit doesn't exist, but our function has a value there. It doesn't have to have the same, the limit doesn't have to be the same as the function value. All right, let's look at some of the examples on the next page, and then we'll talk about another idea that has to do with limits. All right, so we're looking at example 3, and we want the limit as x approaches 1 from the negative. Remember, limits, when we're talking about the limit, we're talking about the y value. We're talking about the function value. So as we're coming in from the left, what is our function approaching as we're coming in from the left here, Natalia? 1. It's getting closer and closer to 1. As we're coming in from the right, what is our function value getting closer and closer to, Chad? 1 also. What's the limit as f of x as x approaches 1? What's the limit of our function? Sonia? So our limit, if it approaches the same value from the left and the right, our limit is whatever that value is. So what would our limit be? 1. From the left it's getting close to 1. From the right it's getting close to 1. What is the function value at 1? I have an open dot. So what does that tell me about our function? There is no value at f equals 1. So the function at x equals 1 does not exist. The limit and the function don't have to be the same. All right, let's look at example 4. As we get closer and closer to 1 from the negative side, what is my function getting close to, Jordan? Getting closer and closer to 1. As I'm coming in from the right, what's my function getting close to, John? 1 again. So what's my limit? Limit has to be 1. What's the function value at x equals 1 for this particular function? David?
I don't know.
Where's the closed dot? -2. The graph tells us the function value at x equals 1 is -2. That's where my closed dot is. The limit and the function do not have to be the same. My limit is 1, but my function value is -2. Let's look at example 5. Here we're looking at the limit as x approaches 0. So as x approaches 0, what is the function getting close to, Brandon? Getting close to 1. As I come in from the left, my y value is getting close to 1. How about if I come in from the right? Lorenzo? 1 also. So what's my limit as x approaches 0? Andrew? It's the same from the left and the right, so my limit is 1. What's the function value at 0? Kira? Do we have an open dot there? Our graph just goes right through. It's just 1. So our limits from both sides are 1, so the limit's 1 and the function value is 1. So for this particular function, the limit and the function value are the same. And we tend to like to work with functions where the limit and the function value are the same. They behave nicely. All right, now we have something a little different going on here. For example 6. So as we approach 2, as we approach x equals 2 from the negative side, what's happening to our function, Alex? It's increasing, and we have a vertical asymptote, so it keeps getting higher and higher. So as we get closer and closer to, what do we say what's it going towards? What's this? Infinity. It's getting as big as we can possibly imagine. So it goes to infinity. How about as we go towards x equals 2 from the right? It's going down, down, it keeps getting smaller and smaller, so this would be negative infinity. So what is the limit as x approaches 2 of our function? Alec? Does not exist. It's different from the left and right. Does not exist. What's our function value at x equals 2? Or -2? Sorry, x equals 2. What's our function value? Does not exist. So our limits don't exist and our function doesn't exist at x equals 2. All right, let's look at the last 2 examples and then we'll talk about a different idea with limits. So there are our last 2 examples. So as we're approaching -2 from the left, from the negative side, what's happening? What's our function approaching, Max? It's approaching infinity. It gets bigger and bigger and bigger and bigger. How about as we approach 2 from the right? What is our function? What's our function doing? Shen? Also infinity. It keeps going up and up and up and up. So that's infinity. So what is our limit as x approaches 2? Erica? It's the same from the left and the right? So our limit as we go from the left is infinity, from the right is infinity. So as long as it's the same from the left and the right, the limit is whatever it is that we're getting close to. So what are we getting close to from the left and the right? What does this tell us? From the left, infinity. From the right, infinity. So our limit would be infinity. What is our function value at -2? Does not exist if we have an asymptote, so it does not exist. All right.
If you have an asymptote that doesn't exist.
The function doesn't exist, right?
Okay, and then, but if you have the closed.
Right, and we'll talk about that on the next one. All right, let's look at example 8. Listen up, guys. This one, come on, guys. So this one is the same. These two are the same. Our limit is infinity. Except what does this tell us our function value is at x equals -2? 0. We have a closed dot at 0. So our function value is 0. So just a little different situation. Because we have this closed dot, our function has a value at x equals 0. All right, any questions on what we've done so far? All right, now we want to know what happens. So these last 8 examples that we've done have to do with what happens as x approaches a number. We've talked about x approaching -1, -2, whatever. So x is approaching a number. We also are interested in the limit as x approaches infinity. So what happens as x approaches infinity? And that's what the next page of your packet is about. So let's look at that page. So the next page of your packet. So the last examples again, we're talking about as x approaches a number. This is the limit. We're talking about limits as x approaches infinity. So just slightly different ideas. When we're talking about what happens as x approaches infinity, we've talked about this a little bit before already when we talked about rational functions. What we're talking about is what happens eventually. What happens when x gets really large? What happens when we go way far to the left or way far to the right? What is the end behavior? That's what we're talking about as the limit as x approaches infinity. We're talking about the end behavior. What happens eventually? And our notation is the limit as x approaches infinity or the limit as x approaches negative infinity. So as x gets really, really, really large, what happens to our function? What's the end behavior? Now we have a question in the middle here. It says, it doesn't make any sense to talk about the limit as we approach infinity from the left or from the right. Why wouldn't it make any sense to talk about approaching infinity from the left and the right? Can we get further out than infinity and come then towards infinity from the right? You can't get further out than infinity. You can't get further left than infinity. So it doesn't make sense to come at it from both directions because you're just getting bigger and bigger. So you can't get on two sides of infinity. There aren't two sides of infinity. So I guess we could, in shorthand, we could say we can't get to the right or left. We can't get to the right or left. We can't get to the right of positive infinity. We can't get to the left of negative infinity. We're just getting bigger and bigger or smaller and smaller. So we only have 4 cases when for x approaches the limit as x approaches infinity and x approaches negative infinity. And we talked about these with rational functions. Either the end behavior is up, 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 down, So it either has to go to positive infinity, negative infinity, or we could have asymptotes, horizontal asymptotes. And we tell that by looking at the graph. So on this particular graph, we have a parabola. So as x gets really, really large, negative, what happens to y? If we're over here, we keep going here, our parabola keeps going up. So what's happening to our function? It's approaching what? Does it get smaller as we go this way? Or larger? Larger? So if it keeps getting larger and larger, what is it approaching? Infinity. Our function is approaching infinity. It's larger and larger and larger. In this case, as x approaches infinity and it says negative, let's look at that. I want to change that to a positive. So in your notes, change this to a positive. So as x approaches positive infinity, what is happening to our y values? They're negative, they keep getting smaller and smaller and smaller and smaller. So what's going to be our limit as x approaches infinity here? Keeps going down, 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 it gets bigger and bigger, negative. So what's our limit going to be? Negative infinity. Keeps going down, keeps getting smaller and smaller and smaller, or bigger and bigger, bigger negative numbers. So our limit's negative infinity. If it keeps going down to the negative, our limit is going to be negative infinity. So those are our first two possibilities. It's either getting bigger and bigger or smaller and smaller. Our next two possibilities have to do with asymptotes. So this is our third possibility, is we can have a horizontal asymptote. And we talked about horizontal asymptotes when we talked about rational functions. So in these cases, we have horizontal asymptotes. So looking at this graph, as x approaches positive infinity, what is my function getting closer and closer to here, Kevin? What's that? So we're getting closer. I have a horizontal asymptote. It's getting closer to 1. So it's getting closer and closer to this asymptote. So the limit as x approaches infinity is 1. It gets closer and closer to this horizontal asymptote. As x approaches negative infinity, what is my function getting closer and closer to? Dane? On this one. Negative 1. We have a horizontal asymptote at negative 1. So it gets closer and closer to negative 1.
So you just check, you're just looking at the asymptote.
You're just looking at the asymptotes. If it has a horizontal asymptote, then that's your limit. Your horizontal asymptote is your limit. How about example 12? As x approaches infinity, what's happening here on example 12, Autumn? It's approaching 0. It's going back and forth, but it gets smaller and smaller and smaller. So it would be 0. And how about the limit as x approaches negative infinity? It's doing the same thing. It gets smaller and smaller and smaller. So our limit would be 0. So the homework is all just looking at these graphs and finding your limits. So your homework is the graphs 1 through, you have 18 graphs to look at. So your homework is finding the limits on those 18 graphs using the ideas that we just talked about. Any questions On Monday, we'll talk about algebraic limits. If we don't have the graph, if we just have the function, how do we find the limits using algebra?